What are AI agents and their use cases?
At 4 a.m, something read every market-moving headline from the last 12 hours, cross-checked them against a watch list, worked out which ones actually mattered, sized a position against a set of rules, and prepared a buy order. Then it stopped and waited for a human. Nobody wrote the steps. It worked them out. That gap is the whole story of AI agents. You've probably used AI that writes you an answer. You paste in a question, you get a good paragraph, and then you go and do the actual work yourself. What I just showed you is different in kind, not degree, and most of the guidance out there is either breathless hype or a toy demo that sorts your email. This video is neither. So, first, what an agent actually is, in plain language. Then, 5 real use cases, and I've deliberately picked hard ones, the kind that could not be written as a script. Then, we build one together, twice, once with no programming at all, and once in about 15 lines of code. And at the end, the part nobody covers, when you should absolutely not build one. That last part matters more than it sounds. Gartner expects more than 40% of agent and AI projects to be canceled by the end of 2027. Not because the technology doesn't work, because people keep building agents for jobs that never needed one. There's a one-sentence test that tells the difference, and you'll have it by the end. I'm Kate. Let's get into it. Anthropic, the company benefits that makes Claude, defines it about as cleanly as anyone. An agent is a system where the AI, quote, dynamically directs its own processes and tool usage, maintaining control over how it accomplishes tasks. Strip out the formality. You describe the goal, the AI works out the steps. The important word is tools. Without tools, an AI can only produce text. With tools, it can read a file, run a command, query an API, place an order, act on the world, and then see what happened. Every agent, however sophisticated, runs the same loop. It receives your goal, it evaluates where things stand, and decides what to do next. It calls a tool. The result comes back, and that result changes what it decides next. Then, round again. It keeps going until it produces an answer that needs no more tools, and that's how it knows it's done. That's the whole mechanism. Everything in this video is a variation on those 4 boxes. Now the distinction everything depends on. A chatbot answers, you do the work. A workflow is where the AI runs through, quote, predefined code paths. You decide the steps in advance, and the AI fills in each blank. An agent decides the steps itself. Here's the test. If you can draw the steps on a whiteboard before you start, and they're the same every time, you want a workflow. If you genuinely cannot predict how many steps it'll take because it depends on what's found along the way, that's an agent. Hold on to that. It's the most valuable idea in this video. So let's look at 5 agents doing work you could not write as a script. And watch for one thing in all 5. The moment the agent refuses to do something, or stops and asks. That's not a limitation. That's the whole design. Use case 1, and the most consequential. Overnight, an agent scans the market for unusual moves. For each one, it goes and finds out why, reading filings, earnings releases, and reputable coverage. Then, it checks each candidate against criteria you gave it in advance. Sector, market cap, what kind of catalyst counts, how much evidence you require. It sizes a position against your risk rules. And then, it prepares the order. Notice why this can't be a workflow. The number of steps depends entirely on what moved and why. 14 movers might mean 40 tool calls, or 400. Nobody can draw that path in advance. Here's the part I actually want you to look at. This stock passed. Earnings beat, confirmed by 2 independent sources, inside the sector you specified, market cap in range, and the position size to 2% of the portfolio, because that's the rule it was given. And this one failed. The move was bigger, up 9%, but the only source was a single unconfirmed report. The agent rejected it. Not because it couldn't find a reason to buy, but because the reason didn't meet the evidence standard it was given. An agent that only ever says yes isn't applying your criteria, it's rationalizing. And then the part that matters most. It stops. The order is staged. Quantity, limit price, rationale, all prepared. And it sits there until a person releases it. To be very clear, this agent does not place the trade. It prepares it and waits. That is a deliberate design decision, not a technical limitation. The tool to execute exists, and it would be trivial to connect. Keeping a human on the last click is what makes the difference between a system your compliance team will approve and one that ends up in the 40% that get canceled. Everything upstream of that click is where the value is. This is illustrative, by the way. It's not investment advice, and I'm not suggesting you wire an agent to your brokerage account this weekend. Use case 2. 3 a.m, production is down. Alerts are firing from 3 different services, and none of them individually tells you what's wrong. The agent starts where a good engineer would. It doesn't trust the alerts, it correlates them. 3 symptoms, 1 underlying cause. Then it forms a hypothesis and does something genuinely clever. It goes back through the last 40 deploys and bisects them, testing its theory against each one until it lands on a single commit. Count the decisions there. Which alerts to correlate? Whether the pattern is 1 cause or 3. Which deploys are even candidates? How far back to look? Not one of those was pre-programmed. Each depended on what the previous step returned. 9 turns from alert to root cause, at a time of night when a human takes 40 minutes just to get oriented. And then it pages someone. It has the rollback drafted, it knows the blast radius is 2 services, and it does not run it. Think about why. Rolling back production is irreversible, and it's exactly the kind of judgment where context the agent can't see matters. Maybe there's a customer demo running. Maybe that commit is load-bearing for something else. So the agent does the 40 minutes of work that a tired human does badly, and hands over the 10-second decision that a human does well. That division is the entire design pattern. And it's worth stealing whatever you're building. Quick pause. If that incident example landed, hit like. It genuinely helps this reach other people trying to work out where agents actually fit. Subscribe for the rest of the series. Right, 3 more, and the next one is the best demonstration of multiple agents working at once that I can show you. Use case 3, a 60-page vendor contract. And you need to know what's wrong with it before Friday. One agent reading 60 pages end-to-end does an acceptable job of everything, and a great job of nothing. By page 50, it's carrying too much, and the early detail has blurred. So instead, 4 specialists run at the same time. 1 reads only for liability, 1 only for data and privacy, 1 only for termination, 1 only for payment terms. Each one gets its own instructions, its own expertise, and this is the important bit, its own clean memory. The privacy agent never sees the payment agent's reasoning. They finish in the time of the slowest one, rather than the sum of all 4, and they return 11 findings between them. Then the lead agent does the job you actually needed. 11 findings is not an answer, it's homework. It reconciles them, drops the boilerplate, and surfaces 3 that genuinely matter. And look at the top one. This is the thing a single reader almost always misses. Clause 14.2 contradicts Clause 9. The liability agent flagged 14.2. The termination agent flagged 9. Neither one on its own saw a problem. The conflict only exists when you put their findings side by side. That's an emergent finding. No individual agent had enough information to catch it. That's what people mean by multi-agent systems. And it isn't about speed. It's that specialists with clean context find things a generalist misses, and the reconciliation step finds things none of the specialists could see. The cost is real, though. 4 agents is roughly 4 times the tokens, and you're paying for a coordinator on top. Use case 4. Migrate 340 files off the deprecated auth library. This is the one people think is impossible, and it's actually the most mechanical of the 5. The agent plans first, then fans out. 12 workers running in parallel, each in an isolated copy of the repository so they can't collide with each other. Each worker converts its files, runs the tests, and reports back. And here's the bit that makes it trustworthy rather than terrifying. It is bounded before it starts. A cap on how many run at once, a cap on how deep the delegation can nest, and a hard budget in dollars. It stops when it reaches the number, whatever state it's in. 318 converted cleanly. 19 failed the tests on the first attempt, got a second pass, and went through. And 3 did not. The agent looked at those 3, worked out that the auth logic genuinely differs there. They're not mechanical conversions. Somebody made a deliberate decision in that code and escalated them instead of forcing them through. That is the single most important number on this screen. An agent that reported 340 out of 340 would be lying, and you'd find out in production. $4.12 against a $10 cap, and the 3 hard ones land on a human's desk with an explanation of why. Use case 5 is different from the other 4 because it doesn't finish. It runs every week and it remembers. It watches a handful of competitors, pricing pages, documentation, change logs, job postings, and almost every week the honest answer is nothing happened. Week 6. It saw 41 changes and reported 38 of them as noise. Copy tweaks, a new blog post, a typo fix. Silence is the correct output, and an agent that files a report every week regardless is one you'll stop reading by week 3. Then 3 things line up. A new enterprise tier appears on the pricing page, 12 infrastructure roles get posted, a SOC 2 compliance page goes live. Individually, none of those is news. Together, they're a strategy. That company is moving upmarket, and the agent says so, with the evidence that led it there and an explicit confidence level. Medium, not high, because it's an inference rather than an announcement. 2 things make this work over months rather than minutes. It remembers what it already told you, so you don't get the same finding every week, and it distinguishes what it observed from what it concluded. Those are different claims, and a good agent never blurs them. Ask any agent you build for that separation. Right, 5 agents, none of which could have been written as a script. So how do you actually build one? Twice. First with no code at all. Here's what surprises people. In Claude Code, an agent is a text file, not a program, a markdown file with a few settings at the top. You write who the agent is and what it should do in plain English. Save it in a folder called .claude/agents, and it exists. Claude picks it up within seconds. That's the whole install. This is a complete working agent. All of it. Between the dashes at the top, 4 settings. Below, in ordinary English, the instructions. That's the entire thing. 4 fields. Name, what you call it, description. And this does more than it looks. It's how Claude decides when to hand work to this agent. So write it like you're telling a colleague when to step in. Tools, what it's allowed to touch. This one gets read and search only, so it physically cannot modify anything. And model, which brain? A cheaper, faster one is plenty for triage-style work. Only name and description are required. The other 2 are you being careful. And notice the last instruction. Never send, never place, never delete. That's the gate from all 5 use cases, written in 1 line. Then you use it 3 ways. Describe what you want, and Claude routes to it automatically, name it directly to force it, or launch a session with it as the default. And if writing the file still feels like a lot, ask Claude to write it for you. Describe the agent you want, and it'll produce the file. That's a completely legitimate way to make your first one. Now, the same idea in code for putting an agent inside your own software. 2 commands to install, then this. Query is the entire agent loop in 1 function. You give it the goal and the settings, and it streams back what the agent is doing as it works. Allowed tools is what it may use. Permission mode is how much it asks first. Max turns and max budget are the caps from the migration example. 15 lines and you have a running agent. Notice how closely it tracks the markdown version. Same 4 ideas: who it is, what it's for, what it can touch, and how careful to be. And that contract example, 4 specialists at once, is Subagents, which you now know how to picture. Your agent spawns helpers for focused jobs. Each starts with a clean slate, and only its final answer returns to the main one. 2 benefits. They run in parallel, so 4 reviews take the time of the slowest rather than the sum, and the main agent's memory stays clean, holding a short summary instead of every page each helper read. Long-running agents live or die on that second point. Every one of those 5 agents stopped somewhere, and none of them stopped by accident. 3 dials. Permissions. What runs automatically and what needs a person. Reading, automatic. Changing a file, ask. Sending, posting, paying, or trading, always a human. Second, a turn limit, because the loop runs until the job is done and improve this has no natural end. Third, a budget cap in real dollars. The migration agent stopped at $4.12 against a $10 ceiling. Set all 3 before the first real run, not after the first surprise. Which brings us back to that 40%. Anthropic's own engineering guidance is blunt about it. Use an agent for open-ended problems where you can't predict the number of steps and can't hard-code a path. Everything else? Use a workflow. If a task is the same 5 steps every time, an agent is the expensive, unpredictable way to do what a simple script does perfectly. You're paying a model to rediscover the same route every single run. Same steps every time? Workflow. Steps depend on what it finds. Agent. Most failed agent projects are workflows wearing a costume. And the tell is unmistakable. Somebody has spent 3 weeks trying to make the agent behave consistently. If you're fighting to make an agent predictable, you wanted a workflow. A month to something real. Week 1, read only. Give it read and search and nothing else, and let it summarize or classify. It cannot break anything, so you can be brave. Week 2, 1 real task you actually repeat. Approval still required on anything that writes. Week 3, add a single tool and watch how the behavior changes. Week 4, set your 3 dials and put it on a schedule. Start read only. That's the advice, and it's how every one of the 5 agents in this video would have started. So, an agent is a loop. Decide, act, look at the result, decide again, until the job's done. Tools are what make it real. The good ones show their evidence, separate what they saw from what they concluded, and tell you how confident they are. 3 dials before you start. Permissions, turns, budget. And the question worth more than the rest. Could you write the steps down in advance? Yes, workflow. No, agent. If you want to see this pattern applied inside a real finance department, the video on screen walks through 5 governed workflows end to end. And tell me in the comments which of those 5 you'd actually deploy first. I read them all, and they decide what I make next. I'm Kate. See you in the next one.